Welcome to building adaptive UIs in Jetpack Compose. Watch this app stretching from a standard vertical phone view into a wide horizontal tablet layout. That seamless transition is our target. This is a side-by-side of the list detail pattern. On the left, the expanded tablet view displays a deep collection of items right next to the selected content, so you always retain your context. On the right, the compact mobile view simply stacks those elements into a single-pane navigation flow. Then we have the supporting pane pattern. Looking at this landscape tablet view, the primary video stays in sharp focus on the left side, while contextual tools like an Up Next queue sit conveniently adjacent on the right. To build these structures, you need to add 3 specific Compose adaptive dependencies to your module's build file: adaptive, adaptive layout, and adaptive navigation. Once you implement these 2 core layout patterns, you have the architectural foundation to solve almost any large screen adaptation problem. Let's write the code. Step 1 is configuring the Android manifest. For devices running Android 15 or lower, you must opt in to predictive back animations by setting Enable on back invoked callback to true. If you skip this manifest configuration on older devices, pressing the back button during a pane transition will forcefully close the entire app instead of returning the user to the previous pane. Next, we set up the scaffold state by calling Remember List Detail Pane Scaffold Navigator. This navigator tracks exactly which part of the dual pane hierarchy is currently active. We then pass that navigator into the Navigatable List Detail Pane scaffold. Inside this scaffold, we map out 2 specific parameters, the list pane and the detail pane. For both of those parameters, you instruct the scaffold how to render your UI by wrapping your content inside the Animated Pane composable function. Animated Pane reads the current window size and automatically executes the complex sliding and fading transitions whenever the device is rotated or resized. By combining the navigator and the scaffold, your app now has a responsive dual pane layout that automatically falls back to single pane navigation for small screens. You skip writing manual breakpoint logic entirely. To programmatically move between these views, call the navigator's navigate_to method and pass it list_detail_pane_scaffold_role.detail. But in a multi-pane environment, the system back button needs strict rules. We handle this with back navigation behavior, which determines exactly what happens when a user tries to reverse their navigation. Look at this diagram for pop until content change. This rule prioritizes viewing history over physical layout. If you click Item 1, then Item 2, pressing back will return the detail pane to Item 1, even if the device physically folds in the middle of the action. Now look at the flow for pop until current destination change. Here, pressing back forces the focus to shift strictly to the previously highlighted navigation element, regardless of whether you are looking at a single mobile screen or an expanded dual pane layout. Explicitly defining these back behaviors prevents users from accidentally exiting your app when they are simply trying to close a split-screen view. The logic shifts slightly when we build the navigable supporting pane scaffold. Instead of a list and its details, this architecture separates a primary focus from a secondary context. We start by calling Remember Supporting Pane Scaffold Navigator. Then we map our composables to the main pane and supporting pane parameters. Inside the main pane, add an action button with an on-click event that calls Supporting Pane Scaffold Role.Supporting. This explicit action pushes the extra context into the view hierarchy. This specific scaffold physically separates essential user tasks from supplemental interactions. On smaller screens, the UI remains perfectly uncluttered until the user deliberately asks for that extra information. Dropping all your UI components directly inside these scaffolds creates massive, unreadable blocks of nested code. To fix this, extract your main pane and supporting pane layouts into their own isolated composable functions. Warning tone, but there is a catch. When you move that code outside the scaffold's curly braces, you lose direct access to the animated pane features. The default transitions will break. To preserve the animations, apply the 3-pane scaffold pane scope extension to your extracted functions. This links your external components directly back to the scaffold's animation system. Extracting panes this way separates a messy visual prototype from a production-ready, highly testable Compose architecture. Let's test the final result. On an expanded tablet screen, tapping a button smoothly slides the supporting pane into the frame alongside the main content. Now, performing that same interaction on a compact mobile screen immediately slides the new detail view entirely over the previous content. You've successfully built a robust Adaptive Material 3 UI. It uses minimal boilerplate, perfectly separates components, and handles window resizing dynamically. The next logical step in adaptive design is primary navigation. Check out our next video to learn how Navigation Suite Scaffold adapts bottom bars into side rails.